Hi, today we are going to discuss another interesting system design pattern called Strangler Fig Pattern. Strangler Fig is a very interesting pattern and this is not very known, which makes it even more interesting because this is actually one of the patterns used heavily in the industry, but not much knowledge is there around this pattern. This basically helps in migration of a monolithic service to microservices architecture, right? How do you do that gradually, safely, without impacting the customers or existing in-flight traffic, right? And if you are working in the industry or even in interviews, this is one of the areas where if you are a senior engineer moving towards a more senior level role, these are the kind of projects almost everyone 99% companies in today's world is doing some kind of migration, right? It's not about writing the core code from one system legacy system to the new system. It's more about how do you do it safely and doing it in flight, right, while there are already production customer traffic being handled. How do you migrate and lift and shift the entire logic underneath without impacting customers, right? We are going to look at the entire pattern. We are going to look at the entire flow, taking an example. And you'll see that it is very simple. I mean, try to think of it in a way where it is what is a pattern that you can follow, right? So without further delay, let's jump straight in. So strangler fig pattern, right? So what is the problem that we are trying to solve? The problem is you have a monolithic application. A monolithic application is something which is filled with multiple features and functionality, right? Which has been built, say, for a long period of time, and now it is very difficult to manage, right? You want to move that one monolithic system to multiple microservices gradually without the risk of a large cutover rewrite, right? I mean, if you have to move the traffic, you don't do that. You don't cut over the traffic by rewriting the entire logic, which will increase a lot of risk. Rather, you should do it gradually, right? The solution is the strangler fig pattern, right? So let's look at how a strangler fig pattern will work, taking an example of a hypothetical example, right? So let's say we have a monolithic service. This monolithic service has four functionalities. Okay, functionality 1, functionality 2, 3, and 4. Functionality or feature, whatever you can call it, right? The user is or the internet, the request is coming via the internet and reaching your monolithic service, and the monolithic service is handling whatever the feature or the use case that is being requested, right? Now, if we have to migrate that to a microservice, right, how will we do that? We will do that by moving piece by piece. We are not going to do a one lift and shift. We are going to do piece by piece, and even for every piece we are going to ensure that the real traffic is not impacted immediately, right? So to do that, let's say we first want to move functionality 1. So what we'll do, we'll create a microservice. We are going to create a facade for functionality 1, right? A facade you can think of is a front facing interface, which is basically masking the more complex underlying or structural code which is residing in the monolithic service. Now, in this case, it can be considered as an interceptor, right, which just fronts the request and delegates the core business logic to the monolith, right? The core functionality still resides in the monolithic service, but the facade is residing in a new microservice, which is directly taking the request. From a customer's perspective, they are not aware how the request is being served in the backend, but in the backend, you have basically created a facade intercepting the call to functionality 1. And for the core business logic, you are transferring that call to the main monolithic service. Once that is done and you are seeing that the traffic is being handled, you have tested it, you can basically then move the entire functionality to the microservice, right? Remove the facade, move the entire functionality to the microservice. So now we are at a stage where we have shifted 25% of the monolithic service, which is say functionality 1, to a new microservice, right? Similarly, if we want to move functionality 2, how will we do? We'll first create a facade of functionality 2, let the request intercept to the facade in the microservice, and the microservice is going to call the core functionality in the monolithic service, right? Once you have tested, you have verified, then you can deprecate the functionality in the monolithic service and uh, create and directly serve the request from the microservice itself, right? Now let's say you want to move functionality 3. Now obviously a monolithic service can have various kinds of functionality all built into one this huge service, right? But in a microservice architecture you don't need to follow the same pattern, right? For example, say the monolithic service that we are considering is a ordering system, right? Functionality 1, 2, 3, 4 can be order processor, or say payment processor, acknowledgement, notification. Those are 4 features, right? You might want to do a order processor and the other feature in one microservice, but you might want to do functionality 3, which is say payment processor, in a different microservice, right? That is possible. So you basically break the monolith into multiple microservices, right? So if you have to do functionality 1 in a different microservice, this is what we are going to do. We are going to create another microservice, create a facade in that microservice for functionality 3, let the request route through F3 facade, and where the business logic is still residing in the monolithic service, right? And once that is tested and verified, you basically deprecate the functionality 3 in the monolithic service and let it directly serve the request from the new microservice, right? So now at this point of time, what we have done, we have created 2 microservices, split the functionalities of the entire monolith into 2 microservices, which are more orderly fashioned. We have done that gradually. Now for functionality 4, while you are doing the migration, you come across and figure out that functionality 4 is not needed in the today's world, in the new architecture, right? So that also can be achieved. At this point of time, you have shifted the entire feature set to microservices architecture, but functionality 4 is still residing in the monolithic service. If you decide that functionality 4 is not needed, not only can you migrate, but also you can deprecate a existing functionality along with the entire monolithic service, because here all the request is going for functionality 4 is only going to monolithic service. Everything else we have shifted out, right? So we are very safe to cut off the monolithic service and deprecate it completely, because that might not be a feature that customers are wanting, right? So at this point of time, your pattern looks something like this, your architecture looks something like this. You have deprecated the monolithic service, you have deprecated functionality 4, which was just residing because it was residing in the legacy monolithic code base. But now when you are migrating, you don't need to migrate functionality 4, right? You only need to migrate functionality 1, 2, 3, and that you have also split into multiple microservices, right? So with single responsibility, for example, right? So this is the way the Strangler Fig pattern works, and this is the way industry operates when you are doing a gradual migration. Basically, you are migrating a monolithic service to microservices architecture, in-flight requests, serving production traffic gradually without the risk, right? So let's look at the benefits of the Strangler Fig pattern. Obviously, like I mentioned, it minimizes risks because you are not directly doing a downtime kind of a thing. You are not moving the traffic at one go, right? You are doing it phase by phase, functionality by functionality, first testing, creating a facade, intercepting the request, keeping the functionality in the monolith till you have verified. If something goes south, you can obviously remove the facade and again read out the request to the monolithic service, right? So it minimizes the risk, it spreads the development effort, right? I mean, you can obviously, like we are doing functionality by functionality, you don't have to do it within a week or a month or a year, right? I mean, you can spread that across and do it at your own pace. There can very well be a scenario where 2 of your functionality is being served from 2 microservices, whereas the remaining 2, 3 are being served from the monolithic service, right? And that is a very safe state to stay. I mean, you don't have to panic that we have not migrated the remaining of the functionality from the monolithic service, and that is a safe place to stay because customers are not being impacted, traffic is being handled. The next is obviously the legacy system deprecation is also safe, like we saw. I mean, if you don't need something, not only does it help in migration, but it also helps in deprecation of an old monolithic system. And like I mentioned, in industry, this is like 99% of the teams or the companies that you can think of have at least 1 or 2 migration project running in every team, right? Because software is always evolving, you will be migrating from, and there are multiple systems in the world today which are still monolith, because microservices architecture is still very new. It's not as old as the monolith. Like previously we used to build things. But there's few considerations I would like your attention on that. Like whenever you're doing that, notice that there will be a potential where your data stores and the services can potentially use both the new and the old, that is the microservice and the monolithic service at the same time, right? So while you are maintaining, at one point of time you are only managing the monolith. Once it is migrated, you will only manage the microservice. But during the migration, it is possible that the request and the data stores, or say the resources, might be potentially reused, right? And might be used by both the systems. So you have to be careful around that. Second is the facade. The facade that you are building, you have to remember that does not itself become a single point of failure. Then that will be an impact to that entire functionality, right? Also, another thing that I should have mentioned is, while you are building this new microservice, try to build it in a way which, if you need to deprecate it again and build another microservice, that can be easily supported. A general pattern that I have seen while doing this migration, folks end up building the new microservice also kind of in a semi monolithic pattern, right? That is not the agenda. So keep that in mind while you are doing that. So this is the Strangler Fig pattern. If you come across any migration project, and if you are working on a monolithic to a microservice architecture migration, I mean, definitely mention this, put this in your design, and these are like things that is not very known, but these can gain a lot of brownie points. Okay, hopefully this was useful.